Good evening, sir.
Yeah, is my voice audible?
Yes, sir.
And the screen, I have just started sharing the screen. Can you see the screen? The pattern.
Yes, sir.
Can you see the PPT? Okay. Yeah. So, good morning, dear students. Today we will discuss about pattern and as well as the dimensions of the pattern. Okay. First of all, in this particular slide, you can see here this one a pattern here you can observe which is called as a model or replica of the casting. Here in these two figures, say for example in the first photograph, you can see here this is called as a pattern. Here you can observe this is called as a pattern. Usually a pattern, it will be made up of wood, okay, which will be the model or replica of the final casting. Okay, what is the definition of the pattern? Here this one and this one, here if you observe, if you consider the second photograph, this is called as a pattern. So here you can observe this is an engine block, okay, an engine block. Here if you observe here, before actually preparing the casting of an engine block, we should prepare first of all a pattern which is called as the model or replica of the casting. The model or replica of the casting, it is called as a pattern. Usually a pattern will be made up of wood or a metal or a wax or a plastic. These are the materials that are used for the preparation of pattern. I will repeat once again. What are the important pattern materials means? We can have a wood, we can choose as a pattern material, or metal also we can choose as a pattern material, and wax and as well as plastic. These are the materials which are used for the preparation of the pattern. So before actually going for the casting process, we need to prepare its replica or we need to prepare its model. That means the model or replica of the casting, it is called as a pattern. And next here you can observe here you can observe pattern. What is the purpose of the pattern? Here with the help of the pattern we are going to prepare the mold cavity. Here in this case, here you can observe this particular example. Here you can observe this is called as a crankshaft. Okay, this is called as a crankshaft. First of all, before actually going for the manufacturing of the crankshaft by using the casting process, I need to prepare a pattern. Here you can observe this is called as a pattern, and then with the help of the pattern I am preparing a mold cavity. Here you can observe this is called as a mold cavity, and then the top molding flask I can call it as a cope box, and the bottom one it is called as a drag box. With the help of this pattern I am preparing the mold cavity, and then after preparing the mold cavity I am pouring the molten metal here, so that the solidified object, here you can observe this is called as a casting. Okay, this particular photograph, it will clearly show you what is called as a pattern and what is the purpose of the pattern. The purpose of the pattern is to prepare the mold cavity, and then into that mold cavity we are pouring the molten metal, and the molten metal after solidification, it is going to take the shape or as well as form of the mold cavity. The mold cavity, with the help of the pattern we are preparing here, the pattern is in turn it is a replica or model of the casting. Like that we need to understand. So whatever the casting or the solidified object is there, that model we are preparing first, which I am calling it as a pattern, and then with the help of the pattern again I am going to create the mold cavity, and then into the mold cavity I am pouring the molten metal, and the molten metal after solidification I am going to obtain the casting. Okay, here what is the purpose of the pattern? Pattern is used to prepare the mold cavity. Here you can observe what is the meaning of the mold cavity. Here you can observe the impression of the pattern that is created in the sand. Here you can observe this is called as a molding sand, and then the impression of the pattern is created in the molding sand, and that impression I am calling it as a mold cavity. With the help of the pattern I am preparing the mold cavity, and into the mold cavity I am pouring the molten metal, and the molten metal after solidification I am going to get a cast. Okay, this is called as a introduction for the pattern. What is called as a pattern? It is the model or replica of the casting. And next one, what is the purpose of the pattern? Pattern is used to prepare mold cavity. Without pattern, we are not going to create the mold cavity, and then the entire casting process here, if you observe, without a proper pattern, here you can observe here, if the dimensions of the pattern are more or less, that in turn it is going to affect the dimensions of the casting. Okay, and next, here you can observe what are the materials that are used for the pattern. Here you can observe patterns are made up of either wood or metal. What is the drawback of choosing wood as a pattern material? Means wood. So the sand which we are using, the molding sand which we are using, it consists of moisture. if the wood absorbs the moisture, what will happen? The pattern dimensions are going to change. So that is the problem with the wood. If you use wood as a pattern material, the molding sand surrounding the pattern, it consists of moisture. If the wooden pattern absorbs that moisture, here you can observe the wooden pattern is going to change its dimension. By absorbing the water or by absorbing the moisture, the dimensions of the wooden pattern are going to change, and then it is in turn going to affect the dimensional characteristics of the casting. That's why here we are having an alternate for the wood. We can use metal as a pattern material, or in terms, if you observe the investment casting process, where we are using wax can be used as a pattern material, and a plastic also sometimes can be used as a pattern material. That means in order to create the what we call, in order to create the model or replica of the casting, we can choose either wood or we can choose either metal, and we can choose either metal in the sense aluminum pattern. We can make use of aluminum pattern, and wax also can be used as a pattern material, and a plastic can also be used as a pattern material. So patterns can be made up of either wood or metal. And next, here if you observe, the patterns are made up of somewhat larger than the final job to be produced. So an important question will be, question arises, are the dimensions of the pattern and the dimensions of the casting are same? Here you can observe the pattern is somewhat made larger than the casting. Why? Because this excessive amount of dimension, it is referred to as pattern allowances. That means, so the answer for that question, are the dimensions of the pattern and the dimensions of the casting are same? No, the pattern is weighed somewhat larger than the dimensions of the casting. This excess amount of dimension, here we are referring it as pattern allowance. That means here the takeaway point is the pattern is made somewhat larger than that of the casting. Whatever the casting that we require, whatever the dimensions of the casting, we are making a bigger pattern, and then with that bigger pattern we are creating the mold cavity, and then we are pouring the molten metal, and after solidification we are going to get the casting of desired size. That means the patterns are made somewhat larger than the casting. So that is the takeaway point here. The patterns are made somewhat larger than the dimensions of the casting to be produced. This amount of excess amount of dimension that I am providing here, that is called as a pattern allowance. Now in the next coming slides, we will going to discuss about what is a necessity for the pattern allowance and what are the different types of pattern allowances. Okay. Here remember one point, pattern is made somewhat larger than that of the casting. Why so? Why that pattern is bigger in size than that of the casting means, here in one of the videos that I have played in the yesterday's class, while removing the pattern, that means after performing the ramming operation and all those things, while removing the pattern, what we are doing here, we are inserting the draw spike, and then we are little bit shaking the pattern. During the shaking of the pattern, what will happen? The mold cavity will get enlarged. Like that, some kind of concepts are involved here. Why that pattern is made somewhat larger than that of the casting, that we are going to see in this class. Okay, that excess amount of material that we have provided on the pattern, that is called as a pattern allowance. Okay, so the important thing you need to remember, pattern will be always larger than that of the casting. This excess amount of variation in the dimensions of the pattern and the casting, it is called as a pattern allowance. Here you can observe these are the pattern allowances. Here starting with the shrinkage allowance, and as well as we are going to have draft or taper allowance, and then machining allowance. After that, distortion allowance. Here you can observe distortion allowance, and the last one, wrapping or shaking allowance. Okay, here you can observe the first four, we can call it as positive allowances. Here you can observe the first four are called as positive allowances, and the last one is called as a negative allowance. Please make a note of these. So among the pattern allowances, the wrapping or shaking allowance, it is called as the negative allowance. Why it is called as a negative allowance? Why these four are called as the positive allowances means, here shrinkage allowance, draft allowance, machining allowance, and the distortion allowance. In all these four cases, we are making the pattern bigger in size than that of the casting. But whereas finally the wrapping or shaking allowance, we need to subtract the value. Why? Because while wrapping or shaking, what will happen? The mold cavity size will get enlarged. That's why in order to compensate that one, we need to subtract the value of the wrapping or shaking allowance. That's why it is called as a negative allowance. So once again I am going to remind what is the meaning of the pattern allowance. So there arises a question. So sir, you are saying pattern is the model or replica of the casting. But why again these pattern allowance means? Here you can observe, I will ask one simple question. The casting. So the casting, it will deals with the raw material which we are using in the casting is in which state? Is in gaseous state, liquid state, or solid state? Can anyone answer? Casting primarily the raw material which we are using, it will be in which state? Whether it is solid, liquid, or gaseous? Hello?
Liquid.
Liquid. So we are pouring the liquid metal into the mold cavity, right? And then after solidification, we are going to get the final object called as casting. So during the solidification, what will happen means the metal will get contracted. That means we are pouring the metal in the liquid state, and during solidification, the metal will be get contracted. So you already know the concept of whenever we heat the metal, it will expand, and whenever it comes down to room temperature, again it will be going to get contracted. That means expansion and contraction of the metal will takes place. But in the case of the casting, we are pouring the liquid metal, and then during solidification the metal will get contracted in size. So in order to have such kind of a thing, here you can observe a pattern will be made slightly bigger in size than that of the casting. So overall we can define pattern as a model or replica of the casting with pattern allowances. The pattern will have certain allowances, that means plus or minus the dimensions of the casting. Okay, now we will discuss about what are the various allowances here. Meanwhile, you please make a note of these pattern allowances: shrinkage allowance, draft or pattern allowance, and then machining allowance. After that, distortion allowance, and then wrapping or shaking allowance. Among these 5 different types of allowances, here you can observe wrapping or shaking allowance. It is called as a negative allowance. We need to subtract. We need to subtract the value of the wrapping or shaking allowance. Okay, first of all we will see what is the necessity for providing the shrinkage allowance. Here you can observe the molecules here. If you observe, if here you can observe in the case of gaseous state, the molecules will spread out, and then observe the spacing between the molecules. If you understand this particular photograph, you can easily recall what is the purpose of providing the shrinkage allowance. Here you can observe in the gaseous state the molecules are spread out, and then they are having more amount of space between them. But whereas when it comes to liquid state, somewhat the space will be get lesser. And then when it comes to solid state, here you can observe the spacing. Here you can observe the spacing will get minimized. Here what will happen here, the heat will make the molecules to spread out, and in turn if it makes get cooled, if it gets cooled, what will happen, it will make the molecules to get squeezed together, and then it will be get turned into liquid or solid. That means in the gaseous state, more amount of spacing is there between the molecules, but whereas lesser amount of space is there in liquid, and still the space will get more amount of lesser in the case of the solid. That's why here you can observe, in order to provide compensation for the shrinkage of the metal, here we are pouring the molten metal at the elevated temperatures. That means the metal is in liquid state. How it gets into liquid state? We are heating the metal in a furnace so that the solid raw material is get converted into liquid. At that elevated temperature only, we are pouring the molten metal into the mold cavity. So during the solidification, based upon the spacing between the molecules, the material will get contracted. In order to compensate for the shrinkage of the material, we are providing this shrinkage allowance. What is the purpose of providing the shrinkage allowance? In order to provide compensation for the shrinkage of the material, we are providing the shrinkage allowance. What we will do in the case of this shrinkage allowance, we will make a pattern which is bigger in size than that of the casting. That means a pattern is prepared which is bigger in size than that of the casting. And then is there any formula to calculate the shrinkage allowance? Yes, here you can observe shrinkage allowance is equal to alpha into L, where L will denote the length of the casting, and then theta F will denote the freezing point of the material, and theta 0 it is going to represent the room temperature. That means here on what factors the shrinkage allowance value will depend upon? Shrinkage allowance value will depend upon linear coefficient of thermal expansion of the material, and as well as the length of the casting, and as well as what is the freezing point of the material and as well as the room temperature. That means based upon all these points, the shrinkage allowance will depend upon. Again, it will vary from material to material. You already know here you can observe different materials will behave in a different manner according to the linear coefficient of the thermal expansion. That means the amount of shrinkage allowance will depend upon a particular property of a material that we are using. What is that property? Linear coefficient of thermal expansion. The amount of shrinkage value will depends upon the linear coefficient of thermal expansion, how that particular material will behave at the elevated temperatures. Okay. And next, these are some of the materials and as well as the shrinkage allowances. That means, say for example, if you take cast iron, here you can see here cast iron 10 mm per meter length. That means if you are preparing a casting of the length of the casting as 1 meter, you have to provide an allowance, a shrinkage allowance of 10 mm, like that. If you are using aluminum as a raw material for the preparation of the casting, for every 1 meter length of the casting, we need to add a value of 12 to 15 mm, like that. That means the extra amount of material which we are providing in the pattern in order to compensate for its shrinkage. Why? Because we are pouring these aluminum, casting, bronze at the pouring temperature, which is higher than that of the room temperature. When the material gets solidified, when it comes to the room temperature, the molecules will get contracted and then the overall volume of the casting is there, it gets reduced. In order to compensate for that one, initially while preparation of the pattern itself, we are adding a certain extra length here, that is called as shrinkage allowance. So say for example, bronze, if you take, for every 1 meter length of the bronze casting, we need to add a 15 mm extra portion on the pattern. Okay, remember here, these are all the shrinkage allowances which we are providing on the pattern. Why? Because in order to compensate for the shrinkage of the material from liquid to solid, here you can observe here the pattern is made slightly bigger in size. Okay, the slightly bigger in size. So what is that bigger value for each and every material? It will depend upon the linear coefficient of thermal expansion. And then here you can observe these are some of the shrinkage allowances for various materials, cast iron, aluminum, bronze, like that. So these are all some of the examples where this is the value that we want to provide as an extra material in order to compensate for the shrinkage. And next one, what is called as a draft or taper allowance. Observe these two figures over here. Suppose this is a pattern. Here you can observe this is pattern and this is also a pattern. While lifting the pattern upwards, what will happen? Here you can observe while lifting the pattern upwards. Why? Because in order to create this mold cavity into which we have to pour the molten metal, in order to create the mold cavity, we need to remove the pattern with the help of the draw spike. Okay, here you can observe in order to facilitate the easy withdrawal of the pattern without damaging the mold walls, we are providing the draft allowance. What is the meaning of draft allowance or taper allowance? Means here you can observe the vertical surfaces. Observe the vertical surface here and as well as the vertical surface here. Here you can observe the surface here, it is slightly tapered. Here we have provided a certain value here, that is the inclination value alpha. The inclination value alpha will be 0.5 to 2 degrees. Here you can observe rather than making this vertical surface straight, what we are doing here, we are providing the tapered surfaces on the vertical faces of the pattern. Why? Because in order to facilitate the easy withdrawal of the pattern. So just to recall the video that I have played in the previous class. So what the person is doing, he is slightly, here you can observe, he is inserting the draw spikes and then he is slightly shaking the pattern and then he is lifting. Why? Because the sand will be get adhered to this pattern. So in order to get easily withdrawal of the pattern, what we need to do means whatever the vertical surfaces are there, this is the second vertical surface and then this is the third vertical surface and then this is the another one, fourth vertical surfaces. All these vertical surfaces of the pattern are slightly tapered. What is the meaning of the tapered here? Here the diameter will be more and then here the diameter will be less. What is the meaning of the taper? The difference in the diameter when measured over the length, that is called as taper. Okay, to facilitate the easy withdrawal of the pattern, what I am doing on all the vertical surfaces of the pattern, I am providing a taper value. What is the taper value here? 0.5 to 2 degrees. Okay, draft refers to the taper put on the surfaces parallel to the direction of the withdrawal. Here, what is the direction of the withdrawal of the pattern? I have mentioned already here. The direction of the withdrawal of the pattern is upwards. So parallel to that, what is the side here? This is the parallel to the side. So this is the direction of withdrawal of the pattern, and then this is the surface which is parallel to the direction of withdrawal of the pattern. On that surfaces, what I need to do means I need to provide a slight inclination here. A slight inclination of the vertical surfaces of the pattern will be provided in order to make the easy withdrawal of the pattern. That is called as draft allowance or tapered allowance. Next one, machining allowance. Why we will provide the machining allowance means observe the surface of the casting here. Here observe the surface of the casting here. Here you can observe at this particular area where I am highlighting. Observe these two surfaces. It is not having the good amount of surface finish. Okay, here at these two regions, here it doesn't have the good amount of surface finish, and then here you can observe holes are formed, and then the surface is not that much smoother. So what I need to do means I need to perform either grinding operation. Here you can observe I will perform the grinding operation here, so that the surface will become smoother, and then it will be having a good look or aesthetic look. Here you can observe the human psychology. According to the human psychology, a component which is good looking will attract the customer easily. In order to make the component good looking, so the component should have good amount of surface finish. But here you can observe if you use a sand casting process, what will happen if you use a sand casting process means if you use sand casting process, such kind of defects will be formed on the top surface of the workpiece. Again we have to choose the secondary manufacturing process called as grinding. Okay, again we have to perform the grinding operation in order to get the desired amount of dimensional accuracy and as well as surface finish. That means here in order to provide compensation for the machining of the casting, that means here you can observe the component that has taken out from the sand casting process, it further requires machining. Why? Because it is not having the good amount of surface finish over here. What we need to do, we need to again perform the grinding operation to get the desired amount of surface finish. That means in order to compensate for the machining on the casting, here you can observe we are providing a certain extra amount of material, say for example 2 to 3 mm. That means if the diameter of the shaft that is required is 20 mm, we are making it as 22 or 23 mm. Why? Because that extra 1 mm of material we are removing by performing the grinding operation on the surface, so that we can get the surface finish and as well as the dimensional accuracy. That means the pattern is made slightly bigger in size. And then why that pattern is made slightly bigger in size means the casting sometimes it requires further machining. Why? Because in order to get the dimensional accuracy and the surface finish, the casting again it has to undergo a machining operation. That's why we are providing some extra amount of material here. That's why in the case of the machining allowance also the pattern is made slightly bigger in size. Okay, the amount of material again it will depends upon the shape of the casting, the type of material which we are using, machining process that is to be used, degree of accuracy and surface finish required. Remember these 2 points here, the degree of accuracy and as well as the surface finish. In order to provide the closer values, here you can observe in order to get the closer values and as well as the required amount of surface finish, we have to again provide some amount of extra material that we are again removing by grinding or surface finishing operations. We can provide the required amount of surface finish on the component, that is called as the machining allowance. And the next one, distortion allowance. So it is provided on the patterns whose castings tends to distort on cooling. Okay, here you can observe especially this distortion allowance, it can be used in the case of the U-shaped or V-shaped castings. So by using this particular slide, I can explain what is called as a distortion allowance here. Okay, here you can observe this is a U-shaped surface or U-shaped casting that I require. Okay, here you can observe the first one. Here you can observe 3 particular U-shaped items are shown in this particular slide. The first one, what the first one will represent, this is the required shape of the casting. I require a U-shaped casting here. Okay, I require a U-shaped casting. But if I what will happen if I exactly prepare a pattern which will similarly look like this casting, what will happen means the casting will be produced will the casting that was produced will have a slightly distortion here. Why it will get distorted here means this surface and then this surface, it doesn't have adequate amount of support. What will happen means if I exactly prepare a pattern, that means if I am drawing now, suppose if I without providing distortion allowance, okay, remember my words, understand, try to understand my words. So distortion allowance, how to understand distortion allowance? This is the casting I require, okay, this is the U-shaped casting I require. If I exactly prepare a pattern like this, a U-shaped pattern if I prepare, and then if I perform the casting, what is the product that I am going to get? This is the product that I am going to get. Why? Because the vertical surfaces will be get distorted outwards. Why? Because it doesn't have the proper support, so that they will try to fall down. They will try to fall down on either sides. That's why in order to prevent the distortion of the vertical surfaces, what I am doing here, I am using a pattern which is having the distortion in the opposite side. That means in order to prepare a casting like this, I want to choose a pattern which is having the vertical surfaces slightly distorted inside. So this is the pattern I have to choose. If I prepare a pattern like this and then if I perform the casting operation, I am going to get the desired casting. So that is the concept of the distortion allowance. The first figure, it will show the required shape of the casting. If you exactly prepare a pattern like this in the shape of the casting, what will happen? The casting produced will have the distortion. Okay, this is not the component I require. So what I have to do in order to get the desired casting like this, what I have to do means I need to select a pattern which is having the vertical surfaces slightly inwards. So what will happen during the solidification? It will become straighter, and then I am going to get the required amount of required shape of the casting. That is the concept of distortion allowance. So the first one, it is required shape of the casting, and then so if you exactly use a pattern which is like this, what will happen? It is going to produce a casting which will be having the vertical surfaces distorted out. What I need to do in order to compensate that, I have to make these vertical surfaces slightly moved inside, so that after solidification I am going to get the exact sizes. Here the same thing here I require, this is a three-dimensional figure. Here you can observe this is an I-shaped cross-section casting I require. Okay, this is the shape of the casting I require. So if I exactly use a pattern like this, what will happen? Here you can observe the surfaces here exactly in this particular I-shaped casting. Here at this portion and at this portion, there is not adequate support, right? You can observe here there is not adequate amount of support at these two ends. What will happen if I exactly use a pattern which is in the shape of the casting? So it will be get slightly distorted. Okay, it will be get slightly distorted casting. So what I need to do in order to avoid this distortion on the casting, what I am doing here, I am providing, here you can observe I am providing a, here you can observe I am providing the distortion in the opposite side for the pattern. Here you can observe it will be distorted slightly upwards, and then what will happen during the solidification? It will try to bend, or it will be getting distorted, and then it will become straighter. Okay, this is called as distortion allowance. Here you can observe this type of allowance is provided on the castings only if they are distorted during cooling, especially U-shaped. Here you can observe examples are especially U-shaped and as well as V-shaped and as well as I-shaped castings are there, and as well as T-shaped castings. Here you can observe, yes, yeah, you, yes, someone has switched on the mic. Can you please mute? Yeah. So especially, yes, hello.
Sir, you are muted, sir. Sir, sir, you are muted, sir.
So that is not the problem with me. So some students, okay, so who has just joined, rather than muting their mic, they have muted me, okay. Just a minute. So we can identify who has muted me also, okay. Just a minute. This is called as a distortion allowance. Okay, wherever the surfaces of the casting are distorted, we need to provide the pattern, the distortion in the opposite side. Why? Because you already know. So if it is if the casting surface is not properly supported, what will happen? It will be get distorted like this during the solidification. If it gets not properly supported, it will be get distorted. So what I have to do? I have to prepare a pattern in such a way that the distortion will be in the opposite side. If I choose a pattern like this, so what will happen during solidification? It will comes down normally, it will distort and then it will comes down normally and it is going to give you the required shape. So this is called as the distortion allowance. This is called as distortion allowance and as well as a wrapping allowance. So as I have said earlier, the wrapping allowance, I can call it as a negative allowance. So all these previous allowances like what is called as the shrinkage allowance, draft allowance, machining allowance, and as well as the distortion allowance. I am providing, I am adding the value, but in this case, I have to subtract the value. After adding all those things, I need to subtract the wrapping or shaking allowance. Why? Because to compensate for the wrapping done around the boundary of the pattern for making its removal easy. So why I have played a video in the last class means you might have noted some of the points like during the removal of the pattern, he has simply tapping. He has with the help of a trowel, with the help of the wooden handle of the trowel, he is tapping around the pattern and then he is inserting the draw spike and then he is carefully lifting the pattern. So during that tapping or as well as shaking, what will happen means the mold cavity will become bigger. So what I need to do? So the wrapping enlarges the mold cavity which will result in a bigger sized casting. So in order to avoid that, what I can do means I will subtract a small portion of the value wherever the wrapping will happen. I am going to wantedly reduce the size of the pattern and then I can compensate that also. This is called as the wrapping allowance. Okay, so this is a important question that will be asked in your mid examination. Okay, so what is called as a pattern, and after that, what is the purpose of the pattern? You make note down.
Sir,
What
one
are
still wrapping, sir.
wrapping? So what is a wrapping allowance means? Yeah, wrapping allowance. So rather than yes, I will just start the video here. I will show a video how the pattern will be removed. Are you able to see the screen? Yeah, the desktop is visible for you.
Sir. Yes,
Yes,
sir.
sir.
Yeah. I will just play a video and show you. Think you might have noticed yesterday, but once again I will show you. Yeah. Yeah, this is called as a pattern. Then where is the pattern removal? Yeah, yeah. Observe here, this is gate cutting. Okay. Yeah. Observe here, while removing the pattern, he is simply shaking, right? Shaking the pattern. Yeah. Observe here how he will remove the pattern. First of all, he will do tapping so that the pattern will become loose. Okay.
Sir, video struck, sir.
No, it is playing. Slowly it will play. Okay. Yeah, you can see here the tapping that was done by the operator. Have you noticed that? Yeah, here you can see he is tapping the pattern. So that in this case, while tapping, what will happen? The mold cavity will get enlarged. Okay, and also he is simply shaking the pattern for removal. So what will happen during the tapping and shaking? What will happen? The pattern size, the mold cavity size will become bigger. In order to compensate, what we can do means we can make a pattern smaller in size. Okay, in order to compensate the easy removal of the pattern, and as well as in order to compensate for the enlargement of the mold cavity during the pattern removal, we are providing the wrapping or shaking allowance, which is called as a negative allowance. So how he is removing, you can observe here. So first of all, he is inserting the draw spike, and then he will perform the tapping operation. So during that, what will happen? The mold cavity may get slightly enlarged. In order to compensate for that one only, he is providing the wrapping or shaking allowance. So during the tapping, what will happen? The mold cavity's size may get slightly enlarged. In order to compensate for that one, they are providing the wrapping or shaking allowance. So this is called as the mold cavity. Okay. Yeah. Have you noticed that whoever has asked is the meaning of wrapping or shaking allowance? I think you might have noticed that. Okay, to compensate for wrapping done around the boundary of the pattern for making its removal easily, what I have to do? The operator has to perform tapping. He will just take the screwdriver or as well as a trowel. He will simply tap around the boundaries of the pattern. So what will happen during that tapping? He will exert some amount of pressure on the pattern. Due to that pressure, the mold cavity may get slightly bigger. In order to compensate for that one, the pattern dimensions are made smaller than the actual size of the casting. That's why wrapping allowance is called as the negative allowance. Okay, these are all the various allowances that are provided on the pattern. Okay, so have you understood this distortion allowance? Can anyone explain what is distortion allowance? Yeah. What is distortion allowance? Yeah. You just see this figure and then tell me what is the distortion allowance. Hello. So everything was written on this slide. Can you just explain what is distortion allowance? Yeah, 356. Who is roll number 356? Can you answer the question? What is distortion allowance? Yeah,
Uh,
356. Yeah.
sir,
Who is speaking?
sir, Kishore, sir.
It's not 356. What about, just wait a minute. What about 356? Is
Hello,
not there in the meeting. Yeah.
356, sir.
Yeah, tell me, what is distortion allowance?
Sir, to prepare U-shaped casting,
Yeah, okay.
uh, casting must be done uh, by compressing, sir. Uh,
Compressing.
yes, sir. Means if we provide exact shape, exact
Yeah,
U-shape,
what's your name? Kishore is
Kishore,
speaking.
sir.
Yeah, you see the figure and then try to explain. Are you able to see this slide that I have kept?
Yes, sir. Yes, sir.
You see that figure, and then what you understood from that figure, you tell me. Just read this slide for a particular second, then you can easily explain what is the meaning of distortion allowance. Yeah. So there are three photographs are there, 1, 2, and 3. Just
Yes,
observe
sir.
those figures.
First, we require U-shaped casting, sir.
Yeah, good. Okay. After that,
Yes, sir. To produce U-shaped casting,
okay.
we need to
We need to use which type of pattern, you tell me. Second one or third one?
third one, sir.
Third one. Why? Because what is the second figure will represent? Second figure will represent if you use a pattern which is having
U-shape.
the exact shape of the pattern. If you use a
Yes,
pattern which is having exact shape of the casting, you are going to obtain like this. The walls will be slightly distorted, right?
yes, sir.
What is
Yes.
the third one?
If we, yes, sir.
Explain. What is the third figure will explain?
Pattern provided with chamber
Allowance. Pattern provided with the camber allowance. That means the walls are slightly distorted inwards.
inwards, sir. Yes, sir.
So we can
If
understand like
we
this.
distort inwards,
Yeah.
we'll get exact U-shaped castings.
So if we distort the walls of the pattern inwards, we are going to get the exact shape of the U-shaped casting. Why? Because that yeah, good man. Yeah, you can mute the mic. Why? Because these vertical surfaces, especially in the case of V and as well as I and alphabet T, if you observe some of the portions of these kind of castings, they have inadequate support. They are not properly supported. The horizontal surface here, if you observe, it is not properly supported. What happens if it is not properly supported? The casting will get easily distorted. In order to compensate that one, we are wantedly distorting on the opposite side so that during solidification we are going to get the required casting. Yeah, next I will call another student. Yeah. Yeah, 373. Are you there? 73 ma. The 373. No. No response from 373. 370. His name is Kaja. Kaja Mohiuddin. 370. 370. Yeah. Now if I ask questions slowly, the yeah, anyone from lateral entry 24, are you there, ma? Lateral entry 24. LE 24. Anyone from lateral entry 16 to 24, you are there in the class. 16, 17, 18, 20, 23, 24. Anyone, can you explain what is a draft allowance means? What is draft allowance? Yes. What is draft allowance, ma? See, no one is, yeah.
Sir,
18, yeah, right, ma. Tell me what is draft allowance. Observe the, are you able to see this slide?
yes, sir.
Explain these two figures. What is draft allowance?
Sir, in this first draft, we can
In this first photograph, okay? Okay, first
yes,
photograph. Yeah.
first
Tell me.
photograph. We need certain without draft we need to pull up sir, upwards sir. This
Okay.
in this parallel we need to use the draft allowance.
Are you able to see the screen?
Yes, sir.
Yeah. In the first photograph, can you see the cracks here? Are
Yeah,
you
sir.
able to see the cracks?
Yes, yes, sir.
In the second figure, are the cracks are there?
No, sir.
No. Why that cracks are not there in the second figure? We can explain that also, right?
Yes, sir.
You have to observe carefully why here the cracks are noted down in the first figure. Why the cracks are not there? What is the difference between these two things, these two patterns? If you understand that, then we can easily answer what is draft allowance. Yeah. You will try once again.
Sir, second one is mold cavity, sir.
This is also mold cavity.
Okay.
This is also mold cavity.
Second,
This is also, yeah.
so excuse me. The second
Yeah.
is that the pattern is removed by the draft allowances or any tool.
What will happen? What is draft allowance? That is my question, right? I have asked you to explain draft allowance. If you are unable to give the answer, at least observe the figure and tell me what is happening in the first figure and what is happening in the second figure. And then you can end up with the answer. What is draft allowance, right? This is also pattern. This is also a pattern. What is draft allowance? Can you explain? Where I have provided the draft allowance? Yes, ma'am. Hello. Yeah, see this I am not. I have not kept an exam or an interview like that. I have just kept the answer on the slide, and then I am asking you to explain. Already once. Yeah, tell me.
For easy withdrawal, sir.
Yeah, for easy withdrawal of what?
And the
For easy
pattern should not be
withdrawal.
broken while drawing, while removing the
Sir,
pattern
there will product taper
in the mold cavity.
surface parallel to the direction control, sir.
Yes, sir.
Yeah. Okay. Okay. Let them answer. Okay. Let them. You have given the correct answer. Let the other students also. Okay. Yeah. 18. LE 18.
Sir,
Yeah. You give your answer, right? Draft allowance.
sir, in this, the pattern can be removed easily with a from the molding material tightly packed around it.
Okay. How it can be easily removed? Why not the first one? Why only the second one can be easily removed?
Because it's in parallel, no, sir.
Parallel to what?
Parallel modeling.
Parallel
Taper.
surface.
Parallel to what? That also there in this slide.
Parallel to the surface, to the taper of the
Parallel to
parallel
the
surface.
direction of withdrawal. So I am withdrawing in this direction, right? And
Yes,
how
sir.
I will remove the pattern vertically upwards. That is the
Upwards.
direction of withdrawal. Okay. According to the direction of withdrawal, what are the surfaces of the pattern which are parallel? This surface will be parallel. This will be parallel, right? So these are all the surfaces which are parallel to the direction of withdrawal. So what I am doing here, I am providing a tapered portion here. Okay. If I provide a tapered portion, okay, I can easily remove the pattern without damaging the mold cavity. Okay, that point was not kept here, but photographically I have explained. So how I have explained here, if I won't provide the draft allowance, if I withdraw the pattern, what will happen to the mold cavity? There are chances that the cracks are formed on the mold cavity. If I provide a tapered portion on the pattern and then if I lift the pattern, here the damage I am avoiding. That means I am protecting the mold cavity without damage. So that is the concept of draft allowance. How I am providing the draft allowance means a slight taper I am providing with respect to the this surface. I am keeping this surface beveled at an angle of 0.5 to 2 degrees. This vertical surface here, if you observe, earlier it was straight, but now I made it an angle here sloping downwards, which is making an angle of 0.5 to 2 degrees. Draft allowance or taper allowance. And then machining allowance, you can easily explain here the casting, the product that you have prepared or the product that you have manufactured. If it is not good looking, so what will happen? The nature of human beings is, so whatever the product is good looking, we will attract. It will attract. Okay, but here you can observe here if it is not having good looking or good amount of surface finish is not there. Further, we need to perform grinding operation. So the purpose of performing the grinding operation here to remove these irregularities. Here you can observe, I can call this red colored portion as an irregular surface, which is not smooth. So if it is having irregular surfaces, I can remove them by performing the grinding operation. That means grinding any machining operation, if you observe, it will consume some amount of material. That means machining basically it is a subtracting process. It will take away some amount of material. మీరు మెషినింగ్ చేసేటప్పుడు చిప్స్ అనేవి ఫామ్ అవుతాయి. When we perform the machining operation, chips will be formed. So the material loss will happen. That's why in order to compensate for the material loss that will happen while performing the machining operation, I will provide this machining allowance. A 1 mm or 2 mm slightly more amount of material I will provide. That material I will remove by performing the grinding operation, and then I am ending up with the component which is having dimensional accuracy and the surface finish. Okay, an important question in your examination point of view. Okay, that's why I have explained here what is a pattern, what is the application of the pattern. So can any I will ask a question, you have to answer. I will ask a basic question here. Yeah, 367, are you there? 67.
Yes, sir.
Yeah, your name is Venkata. Can you tell your name? Venkata
Gautam, sir.
Nagasai, right?
Gautam.
Gautam. 367.
Yes, sir.
But your name it is showing is as Venkata Nagasai.
More is there, sir. It is not visible.
Okay, yeah, good. So what is the purpose of the pattern? Why we will use a pattern in the casting process?
It's a pattern is a replica, sir. For mold cavity, we use pattern.
Okay, the pattern is the model or replica of the casting. Okay, it is used for the preparation of mold cavity.
Yes, sir.
Yeah, the answer should be complete and then meaning should be there. Okay, so the pattern is the model or replica
Yes, sir.
of the casting, and then it is used for preparing the mold cavity. Okay, so that's why I am not including more amount of theory and sentences here. Just one complete sentence I am giving, which will give you the full meaning and the answer. What is a pattern? Pattern is the model or replica of the casting. That also you are editing means okay. So don't edit that. So this is a complete answer. Pattern is the model or replica of the casting. Okay. And why we will use pattern means it is used for preparing the mold cavity. Yeah. 366. Are you there? 366. Shiva Shankar. Are you there, ma? 366. No. Yeah. 350. 19881 A0350.
Yes, sir.
Can you tell what are the applications of the casting process? Yeah, 350. What's your name?
So
Patil, right? Amok. Okay, Amok Patil.
Amog.
What are the applications of casting?
So in casting engines we use and wooden wooden blocks, or steel blocks also.
No, no. What are the applications of casting? Okay. 351.
Yes, sir.
Yeah, what are the applications of casting?
Sir, use it for transporting
Transporting.
automobile or aerospace.
Which particular part of the automobile? Automobile means okay, engine will be there, steering will be there, okay, like that. So many parts will be there. Your car or bus will comprise. But I am asking, what are the applications of casting? Hello. Yeah, 351.
Yes.
Are you able to see the screen? 51.
Yes, sir.
What is this part that is there on the screen? This particular element?
Mount cavity.
No. It is a pattern of which component of the automobile I am asking. You said in automobile we will use casting. So this is a pattern of the component. Pattern of the component of which part? Which part of the automobile? It is a pattern of which component in the automobile? Yeah, this one, what it's look like? What is this? Yeah, anyone? What is this one? The second photograph.
Engine block, sir.
Engine block.
This is an engine block. For the manufacturing of engine block, we can use casting. And this one, anyone from the class?
Connecting rod.
Yeah, connecting rod. Okay,
Crankshaft.
connecting rod.
Yes, sir.
Yeah.
Crankshaft.
Okay, these are all the applications of casting process. Okay, and then we have completed the topic called as pattern and as well as pattern allowances. Okay. Yes, ma'am. Just a minute. I am ending the class here. You join at the next class. Okay, at 11 o'clock. Okay, I am ending the today's session here.
Sir, tomorrow
Sir,
we have
can you
lab, sir.
share that course pack?
PPTs, right? Hello.
Sir.
Okay, I will do one thing. I'm having your WhatsApp group. Okay, I will keep the PDF of the textbook. Okay, and as well as the PPTs.
Sir, course pack also.
Sir, what about course pack, sir?
Yeah, course pack also I will forward. Okay, just now.
Okay, sir.
Okay, yeah. You join at 11 o'clock. Okay, the next class. Okay, thank you.
Sir, tomorrow do we have lab, sir?
But yeah, I forgot to discuss about that. And then the next coming 3 days, you will come to college, right, for the lab.
Yes, sir.
Yes,
Yeah,
sir.
I will put the schedule here in the WhatsApp group. Actually, you are having 3 labs. Anyone are aware of those lab names?
Till now, no, sir.
Till now, no. So I will tell you one thing. Yeah, just a minute. You will be having production technology lab, okay, and as well as internal combustion